I'm Dory, and on this episode of Ask Starbase, I'll be answering a question from Bookworm. Bookworm would like to know, why are there certain gases in the atmosphere? To answer this question, we need to consider how the atmosphere has changed since the formation of the Earth. Paleontologists, geologists, and other scientists who investigate this topic use a combination of observations and mathematics to model what happened on our planet long before the first humans. That being said, these ideas are theoretical, as we don't have the option of creating a brand new planet ourselves. Current evidence suggests that Earth's primordial atmosphere, or the one that would have been formed along with the planet, either completely disappeared or never existed in the first place. Scientists think that the sun would have possibly been able to produce so many particles as it formed that gases on Earth would have been blown away due to the radiation and solar wind. From there, elements that had been trapped in solids within the Earth were eventually able to escape, leading to an atmosphere made of hydrogen sulfide, nitrogen, carbon dioxide, water, methane, ammonia, and the noble gases helium, neon, argon, and krypton. These gases accumulated in the atmosphere due to a combination of volcanic activity and primordial origins. Any lighter gases like hydrogen produced by volcanoes or helium released from rocks could escape the gravitational pull of Earth, while anything more massive couldn't move quickly enough. At this point, about 4.6 billion years ago, the atmosphere was mostly hydrogen sulfide, methane, and carbon dioxide. About 4 billion years ago, as the Earth began to cool, water started to accumulate on the surface of the Earth, creating the oceans. The next big change in the atmosphere happened during the Archean eon over the next 1.5 billion years, when life started to form from materials dissolved in the oceans. These first organisms could use the sulfur from the hydrogen sulfide to generate energy, altering the atmosphere by removing some of that gas. During this period, methane made up most of the air. About 3.5 billion years ago, cyanobacteria started producing oxygen through photosynthesis, taking the carbon dioxide and water out of the oceans and releasing oxygen gas. This gas bubbled up out of the ocean so much that about 2% of the air was oxygen. From 2.6 billion to about 400 million years ago, there was another shift. The oxygen in the air started to react with the methane, removing large portions of it from the atmosphere. Scientists think this happened because more oxidized iron can be found in rock layers formed during this time period. Between 700 and 550 million years ago, some organisms started to use oxygen for aerobic respiration, which also suggests more oxygen was around. At that time, it was estimated that oxygen made up about 4% of the entire atmosphere. As the amount of oxygen in the air increased, it started forming the molecule ozone, eventually creating the ozone layer. Land-based life began about 430 million years ago, including plants and invertebrates, who survived by taking in oxygen. Between 400 million and 290 million years ago, scientists estimate that oxygen actually made up 35% of the air. That's 14% higher than now, while carbon dioxide from the air became part of the bodies of plants and animals, eventually getting trapped in the ground after the organisms died. These carbon sinks reduced the amount of carbon in the air and became the fossil fuels humans use today. About 65 million years ago, scientists believe a 200-kilometer wide asteroid struck the planet around Mexico, resulting in what has been described as an impact winter, killing off large portions of life on the planet, including oxygen-producing plants. From then up until now, the percentages of the major components of our atmosphere, nitrogen at about 78% and oxygen at about 21%, have remained relatively unchanged. Fluctuations happen in a category known as trace gases. This includes any other gas from helium and argon to greenhouse gases like carbon dioxide and methane. Changes in trace gases have been correlated to human activity, including agricultural practices and burning fossil fuels. We will see what the future brings as scientists studying the atmosphere continue to share what they learn about the gases in our air. Thank you for watching this episode of Ask Starbase, and a special thank you to Bookworm for sharing this question. If you have a STEM question, please email it to ask@starbase-ct.com or go to our website, starbase-ct.com, and enter it there. In the meantime, stay safe and be well. Bye!